So in this video, I'm going to talk a little bit about how the zero of potential energy is arbitrary. Earlier, we had a video that discussed how the force was related to the potential energy as the negative position derivative. And we're going to use this to talk about a spring. So just for a moment, we'll rederive this idea of the potential energy of a spring by considering the position derivative of the stretch here. So if that is minus the force, then it is plus Ks. We can go ahead and integrate that. And what you'll get is this idea that the potential energy goes like 1/2 Ks squared. But we're doing an indefinite integral here. So actually, we end up with a constant term. We got rid of this in the notes by considering two positions. But I want to talk about this for a moment where we have this indefinite integral, because this indefinite integral allows us a little bit of freedom. So let's graph the usual 1/2 Ks squared potential energy, which looks like that, right? But because we have this constant term here, we can actually use that to shift this graph up and down. And we can change the potential energy to be positive, more positive or more negative. What is typical to do is to think about a potential energy where the shift is actually negative. So this is, say, some E minimum. And the reason for doing that is because when you talk about the total energy of the system, this is a bounded system in the sense that the mass will oscillate between 2 points. And so we kind of shift this potential energy down so that the total energy is still negative, and we can think about bounded states conceptually in the same way that we did when we were talking about gravitational potential energy, as we talked about in another video. Here was the U for that, and here's the total energy line here. And we talked about having bounded states when the total energy was negative. Similarly, we can think about that here. Here's the total energy of that system, for example. And we have a bounded state. The system will go between two stretched points, namely here and here. So what is typical to think about, or to talk about when you're thinking about potential energy, is to subtract off some constant term. And that allows us to sort of think, as I said, conceptually about the potential energy and bounded states.